want you to take away first an excitement about the future and how this technology is going to change our landscape. I want you to also have an admiration for this technology. This isn't something that has evolved overnight. It has come in the works since the 50s and the 60s, but recently there has been a fundamental change in both energy investment as well as the underlying algorithms and technology that drive the space. And thirdly, I want you to think about a question. I want to leave you today with more questions than answers, and that's intentional. It's only 20 minutes, I can't give you all the answers. So think of a question, come talk to me over the next 2 days, and find out the answer. And if I don't know it, we can try and work it out together. So, firstly, some fundamentals. Just because I know everyone loves hearing about the fundamentals, I'm going to keep it really, really simple. So, I'm going to break it up into two parts. There's the external-facing AI and internal-facing AI. And what this means is the external-facing AI is products and services that you build, your company builds, that interact with people outside of the company. Think of OpenAI's chat models, Midjourney, any of those, they interact with people outside of the company. And then there's internal-facing AI. This might be internal things that help your workflow, email writing, things that accompany documentation that you might want to keep private to your own company. Today we're really going to be focusing mostly on the external-facing AI, but know that there's an entire world of internal-facing AI tools that you can explore and develop as well. So, breaking down AI, it gets rather complicated, because AI itself is a term that's used to describe a lot of different technology. But in simple terms, AI is something that tries to mimic human behavior. Now within there we have three main distinct parts. And even in those parts, there's hundreds, if not thousands, of subparts that cross over and have intersections with each other. But the main three are machine learning, which is a subset of techniques that are used to design a system where typically you have a closed system, which means you can have a start and an end point in a system, and you can predict the entire way through. It works really well for those kinds of games like chess. You make a move in chess, you can predict what mathematically is the best output to do next. And that was done in 1997, which at the time was thought to be impossible. Then we have deep learning. Now deep learning works really well when you get to more complex systems, like the game of advertising or the game of Go. So back a couple of years ago, AlphaGo, made by Google, they made an algorithm that was able to beat the Grandmaster in Go. Again, this time it was thought impossible to do this. You can kind of see a bit of a trend that goes on with this stuff. They also use reinforcement learning in this system as well. Now, reinforcement learning is more of a framework, and it actually uses elements of deep learning inside of it. But it has an agent that tries to work towards a goal in order to get its reward. So the use of AI in media. There's two main focuses currently. And this is only what is at the moment. Every one of those lines and every part of there could have AI linked into it. But at the moment, there's really two main focuses that people or companies are looking at. Firstly, we have generative AI. So there's the likes of Google, Meta, who are making advertising possible through generative AI. They've enabled us to have no longer a one-to-one placement to ad creative concept. They have a one-to-many. You don't need to worry necessarily about creating an MREC and a different size and a different size. They're building technology that allows us to scale advertising and allow the people to focus on the strategy and coming up with a creative idea, rather than spending a lot of time and budget and effort on actually making the exact media elements. Then we move on to the slightly larger and more involved side of this development, WPP and iMedia. What they're doing together is trying to create high-impact creative. TVCs, cinema ads, making everything with AI for a fraction of the cost. They can even use music generated by AI, voice made by AI. Everything from the creative side is starting to be replaced, and not at a slow pace either. This stuff is not coming, it's already here. It's starting to be rolled out, and it will continue to be rolled out. Now, when we go into placement optimization and buying optimization, I come from our TV house, and this is what we do primarily. So we focus on the buying and placement optimization. What we can do here is we can take a dynamic creative, and we can have the one that's highlighted is a product that someone might have seen before. Now, previous to this technology, you might have had similar products. but they're hard to find rules. You might have had other products look by similar users. Again, hard to find rules. This doesn't have hard to find rules. What this does is the AI understands the products, understands the user, understands the product that it's trying to sell, the goal that it wants to achieve, and selects the products from the entire feed in order to make that ad. That has not got any defined rules associated with it. We also then use it to improve cost and efficiency. So, who is the best user? When is the best time to display the ad? What should be displayed on the ads in the dynamic creative? And how much? So we can then understand the propensity for that person to purchase, how likely they are to actually complete that, and the cost and reward associated with that creative. And this all happens in real time as well.
Sweet.
So this is obviously amazing technology, but what actually is special about this technology that can answer the questions that we want? Now this part is going to get a little technical, but I want it to be technical, and I want you to be probably slightly lost by it in order to understand actually how complicated it gets. And this, when you see it, is the most simplified version possible and isn't technically correct. It's a cat. I'm using this cat to show you that this is possible, this is created by Midjourney, and I'm going to show you how you could possibly train a model to recognize that this was a cat and not a dog. So we have inputs, and in this case we say take the pixel data. They might be the numerical representations of each color in that image. We then have layers. These are called hidden layers. There's layers that are connected to that data. Each one of those dots are all connected to each other. You then have more layers and more lines. Now, every single one of those lines in this diagram is an adjustable weight, which means that when it trains, every single one of those lines can be adjusted. This is an incredibly small level. They get thousands, if not millions of times bigger than this. And you can think about how many lines are going to be in those things. That's how many things can be adjusted and fine-tuned. These are mimicking how the brain works. Each one of those dots is a neuron, and each one of those lines is a pathway. And the weight defines the size of the pathway. Each one of those dots is an algorithm or a calculation that is applied to it to make it function. It then finally spits out its predicted result. Now, I've chosen this one to be intentionally correct to show you what happens when it trains. What you do is you send in the cat image. The model tells you it's a dog. Now, what happens is the model then goes, well, if this was a cat, and we should have output cat, what line should have changed in order to make this a cat? And then it will do that. And it will do that and do that and do that again and again and again until it gets it accurate. We train on around about 10,000 iterations. So it means you need to do the training data 10,000 times, and that's not really a fresh one. To train this stuff takes an enormous amount of computing power. And then the possible other outcomes. So when this comes to media and advertising, the types of input we might consider are category, product, size, things about the product, about the business, anything like that that can go into the inputs, because you can then take these kinds of objects and turn them into numbers. You then train your model to then predict things you want to predict, like how much to spend, what products should be displayed in the ad. You then have these different models that basically can have the answers for you. So, onto probably the most interesting part of this presentation, the timeline. So, we're going to get automated dashboarding and reporting very soon. So this is a task that has already been technically possible for a number of months. It's going to be rolling out very soon to probably media agencies and companies. Media mix modeling, and budget allocation. So as you can see, those kind of neural networks, perfect example for media mix modeling. AI used for training and staff upskilling. Now this isn't upskilling on AI, this is AI training staff, consider juniors coming into the industry. All of that, like all of you working have a wealth of knowledge that you'll be used to train the models in order to train then the juniors. And they will be then able to ask the model questions, and it will give them answers as though it was a human answering them. Automation of media tasks, so like setting up campaigns, replying to emails even, website tagging. I know that everyone hates website tagging, it takes a long time to do it, it's a complicated task. That's all possible to be done by AI within probably the next 12 months. In fact, it's technically possible right now, it just takes someone to build that up. Trained agents. So we're going to be starting to develop and build agents that are going to be specifically media and advertised trained, which means that you might be able to give them a campaign, give them a client, and they'll be able to tell you, oh, we need to set up a Facebook campaign, you need to set up a Google campaign. It will then be able to do it for you. It might be able to look at the current setup and then tell you what needs to happen, and then change it for you. We may no longer need to actually do these simple actions, especially the repetitive tasks like downloading a report, doing those things in the future. Company trained models. So we'll start to then get into models trained by the actual company themselves. These will then be highly sophisticated advertising models that will be able to do a lot of tasks, including recommendation and strategy. And then I'm going to very briefly touch on this, but come talk to me after if you want to learn more, but websites are going to be changing. The way we browse and engage with websites at the moment is changing probably in the next 12 months. Again, this technology already exists. But there's going to be agents built into websites where you'll be able to ask websites what you want to do. It will be able to give you the information, book you a service, without you having to navigate from any single page whatsoever. Consumers will then have their own user agents. Those user agents from the consumer will then be able to interact with the website agents. You'll be then able to ask your user agent to do something. You'll be able to then find the information online, interact with website agents, and do it for you on your behalf. So the way we're going to be browsing online will most likely shift in the next couple of years. And it's up to us to work out how we can properly monetize that. And the most interesting thing, which I may have told a couple of people, which might be why there's a few more people here, there's something new that may be coming. And this is probably the most interesting part of this entire presentation. So reinforcement learning. So this big shift is coming, and it is all technically possible at the moment. So the use of reinforcement learning will be able to revolutionize how we buy and consider media going forward. A little overview, because I love doing overviews. We have an agent, environment, action, reward. Now, there's an agent which is a language model, or it's a deep learning model. It's a model that can make decisions. You have an environment, which is the advertising environment. It's all of your data coming in and it's making its own virtual environment. The agent can take actions in that environment, buy a media ad, post something to YouTube. It can then transition people between states and then get rewards. And how does that look like? And this is a very simplified version of it, but this illustrates the purpose of how this agent could actually change the way we look at media. So you have an environment, you have different states. State 1, awareness. State 2 is consideration. And the terminal final state where the agent gets to reward is, say, the conversion. What we want to do is we want to fill that environment with data. We then have possible actions that can be taken in that environment. That could be stuff like Google ads, Meta ads, R ads, out-of-home ads, above-the-line media ads. Any action you want to take and build into it, you can make it do this. Probably by this stage we'll have generative AI filling these ad spaces, so you won't have to then generate, ads instantaneously. It will be able to essentially programmatically create advertising for you after it's decided what it needs to do. You have a user who's in the awareness state. Say that they've seen your ads, but they've never actually visited the website, so they probably understand your brand. They might know it a little bit, but they haven't actually taken the action to come to your website. Well, you have an agent. They observe this information, and they know this user. They then can take a look at this from the bigger picture. They then can ask the question, to move this user to the next state, what actions are most likely to drive this user to the next state? And the reason the AI wants to do this is because it will go after its reward. It wants to get the user to its terminal state because that's the only time that it gets its reward. Therefore, it decides the best plan, and it learns the best plan to do this. And it might be different for different users. We won't even be able to know exactly how this agent thinks. It will be able to predict stuff, kind of like a human would. and you can't exactly dissect a human's brain when going through a media strategy. You just can understand that the media strategy makes sense when it's explained to you. And that's going to be similar to what this is. So it might maybe say, take the action to do Google ads and R ads, because those are obviously both like performance-driving channels to drive them to the website. It will then be able to buy those ads for you, publish those ads, track its results, and see if the user has then moved into the consideration state. It will then make the next best course of action to then move them on to the next state. This is a very oversimplified version, and this isn't exactly actually how the tech would work. It wouldn't have such defined states like this. It would create its own states, which could be hundreds of thousands of states. You know, we consider advertising and media in kind of siloed buckets of information. They don't have that constraint. They might have a million steps along the way in order to get to where it needs to be. And tiny micro movements, an ad here, a placement here, to move them along that journey in the most succinct way in order to get to that terminal state. I need to talk later, and I realized that I've actually gone faster than anticipated, which is surprising. So I've got 3 minutes, so I can field some questions now if you like, or can run through anything more in a bit more detail with you as well. So I'll hand it over to the floor.
We've definitely got time for a couple of questions. I'm going to run the mic around, so you haven't go yet. Yep. Go on.
In steady state, what's possible?
Are you meaning technically possible, as in the technology exists?
What can go to market?
What can go to market? Well, the creative is already going to market. There's obviously the buying and media optimization that we do, which is already in market. Outside of that, the reporting and automation, that can go to market. A lot of the agent stuff, like the web agents, that can go to market pretty much mostly up. Mostly up until the very last part with the reinforcement learning stuff. And even that can technically go to market if someone was to build the system for it. Like that tech exists. They use it in games at the moment, so they can play incredibly sophisticated games with it. So that tech could be applied to advertising. It hasn't yet, but if someone was to build it, it could go to market. But the reporting, the agents, the web agents, the user agents, all of those are currently under development at the moment.
And if you
So,
You're on the mic.
I can shout so
Go for it.
So for now businesses they've got, we're dabbling with all sorts of things trying to learn more and in this, something around sort of creative and media buying and so on forth, how would you get business ready to now to start that journey?
I think it takes a lot of investment and board sign-off, which is probably one of the most difficult things. Like with any new technology, it's not normally the technology that holds it up. It's normally getting the budget approval and companies wanting to invest in something that doesn't have a guaranteed reward. Obviously, when you look at presentations like this or you look at different tech, it makes sense, but a lot of companies, again, hesitant to roll something out because what if in 12 months' time there's a bigger, better AI model that some groundbreaking advancement has happened. So I think getting company approval, doing small tests, making small wins along the way, and getting them larger sign-up on budget is the way forward because it is a big commitment to build stuff like this and to integrate it, but there are a lot of tools and stuff that you can start off using now, show the improvement, get people interested in it, and then build upon those successes.
Thanks very much, Dan. I think we've run out of time, but that's a fascinating session. So big round of applause for Dan.